Hello?
Yeah, I can see your screen.
Good. Okay, so let's continue. Today we can, I think I'm going to talk about a tool which is useful for time tracking. So the one particular use case is when you're doing projects, we have those issues, and there are like people working on that, right? If you become a freelancer or consultants, your clients want to see how much time you work on it. So for software engineering, like people, if you're doing consultants, like you kind of sometimes paid hourly, and like people get an hourly rate. So there are multiple tools can do time tracking. Like there are popular like management softwares, right? Those kind of issues. So if you look at like a popular one like Jira, they have this is similar, like also like project management tool and basically a fancy to-do list. And you do time tracking by by like each individual issue. You get you can do some time tracking your time. And GitLab actually also has this feature. Like if we do things like this is a particular issue, and on this side there's a field called time tracking. And you can also have like some kind of tracking report, like how much time you spend, and you have a log. So there is some command, like you can say you have you can remove your estimate. Like here I estimate to be 1 hour, but like I spent 2 hours. So like estimate and so you can remove estimate. I see the estimate goes away. You also like remove the time spent. So now it becomes clear. So those slash are some kind of commands. Right? Like if I estimate this to be like 1 day, and it basically it's like a accounting law. Accountant start to populate those. 1 day is equal to 8 hours. So it's somewhat intelligent, and I can see I spend 1 hour. I give a note. 1 hour. 1 hour work. So also a note. And I comment on it. Here it get a time tracking report. So this is interesting. As you can see the which one is the latest? Yeah, so this is one of the latest. So there's a node, there is this one. So in this way, like sometimes if you want to like show evidence, right, how much time you work on an issue or solving a problem, this is like a tool to help manage that. And if you have multiple issues, each issue like you have different times, estimate time. If you see in different board, it gives you different visualizations. But this is through the UI, like through the user interface, which is okay. But for developers, if you always like going to type in this, it not be that convenient. Also, the reporting. If you want to export this to like a CSV file and do some sum up, because those are tracked by individual issues. So if you want to track by like multiple people across the whole project, across whole time, you may want to also like have a like export data into a spreadsheet, things like that. So there are people developed some. This is particular useful software called GitLab Time Tracker, or GTT. But this one actually automates some part of the process by have a command line tool to allow you to track the time. So if you install this, it's like a Node.js utility, like by those commands, and have your token. So if you go to GitLab the personal page, you can get a token which grants you access to call the APIs, and then you can use some syntax to like you do some config. Then you can see I start this project on particular issue number. Actually, this GTT tool will start the clock, and also you can like stop it, and most importantly, you can do some reports. So I already set this up, so I can kind of see for this particular project, I have 2 issues open. We can actually just see one issue. If we just see one issue, you can see this. I get a report, pretty much similar from UI, like by time and also by detail entry.
So why does it have like some of them have like a negative sign? Like
Yeah.
Issue 1, it
Yeah.
says -2 hours, 37 minutes.
Yeah.
Spent.
Good question. So you remember there also has the, probably I didn't demo. There is also a remove estimate. So this is like a subtraction. If you remove, so if you think about if you're accountant, right? Accountant never go back and edit entries, even if it's wrong. It only add in like a correction report. So those are like when I issued remove, those are time being removed, like subtracted, and it also have a timestamp. So if you think about you're like an accountant, you do only append only operations. So the remove, like those remove command, it translates to the subtractions. That makes sense. So so
Also, you don't change it, like you don't change what you had, and so you just correct it.
yeah. So if you accountant, right? Like this is like accountant. Like you don't even you can only do append only. It's actually a regulation. If you are a accountant, you cannot change your book. You can only do append only corrections. Right? You think about it that way. So this is trying to kind of have that behavior by timestamp, by everything. If you ever do anything, you can really you see the other things. I'm curious, right? Like you cannot really change it. You can only do corrections. So you can spend time. You can also like remove time spent. So it's like addition and subtraction.
Okay, I get it.
Yeah. So you never directly. It is the same, the equivalent result, right? You change the final value, but it's always a like if you sum all the things up, sum all the values up, it's going to be your current number, and everything has a timestamp. This is pretty. This is for audit. If you really if you really do like a bookkeeping of your accountant never insert a page into their history. They only do like a corrections. So that's the design. So this tool is useful. Like it can report the times, and also you can report like a different format. So like you can report a CSV, so it can be look like this. So if you if you have multiple people and have multiple people work on the same thing, you want to have like spreadsheet, like you can export to Excel, or like other spreadsheet you can do like sum. And some people using this to generate billing, like for showing, like if you're doing consulting work, right, you want to show the client, okay, this is time I spent. Some people do screenshots. Sometimes, like this is like a evidence how much time you spend, tied to each individual issues. So this is saying like actually I just did some research for the school. So I'm trying to do a school's registration system. So with a few people of us trying to come up with some kind of tracking with the existing tools. There are a lot of other existing tools, like Jira is particular one. They're like different integrations, and also you see a lot of vendors, right? Like those software solutions, and those like software as a service, like even GitHub. To some extent, they don't. It seems like they don't directly provide this feature out of box. If you think about this, is actually a useful feature, but you don't really have even GitLab has this feature, you can see, but it's issue level. It doesn't really have a page to really see. I get a cross issue, like this is issue 1, 2, 3, like all the issues of all the project, all the peoples, and have a report. Like people thought it's intentionally kind of leave the markets to those like extension builders, those third-party service as plugins. So if you look at the like Jira, this is like more like enterprise kind of software, like project management tools. It doesn't have this like this export multiple people, multiple issue by default. You need to kind of buy third-party service, right? Some kind of timesheet tracking reports by like a plugin, and pay like the plugin vendor to get this feature. So it's kind of like this industry is having ecosystem of like providing different features using like different companies specialize different things. But if you really think about it, it's really like a essential feature for time tracking, and this is like this GTT is a very useful tool, like open source people, which is free. So it seems like popular among like people just like on a small scale, and also just want to track their things via command line. Cool. So this is the tool, and any questions? Good. This may be useful for like even for other things. Like people, like it's not necessary for software project, but if you like ever have like other project, like even not software, if you have multiple people, you want to track time, you want to have some kind of structure, you want to have some kind of reporting, it can be used this way. And some of the issues, because it is like also a messaging system, also a tracking system. So those like even for client support, sometimes even it's not software project, but like if tracking issues, you can use this a comment, right? Provide a thread. So even for like customer support, some project, not software project, they use this kind of use this feature as like a support thread. Support. So you will see a lot of software converge. Right? There are support, customer support software as a service. There are like a marketing, user management software, but essentially a lot of them start to converge. Right? Some feature overlapping and can kind of replace each other to some extent. Okay. So next, we can shift to a different topic. We have so there are some more progress being made by the developer on the locality project. So the progress is we've been able to we've been able to adding release script for different systems. So if we look at and we're also adding the CI/CD part, which is a file like a GitLab CI, this file. So here it specifies what a command to be run after the repo get merged or get changed, and those are like some commands. There's cargo build command, different cargo build command, building different target, and some linters. So it is using like a Docker image. So this image is a Rust Docker image. Have you heard of like a Docker container in general?
Not really.
Alright. Okay. So Docker, or like you heard about like containers. This is the kind of the environment for have a virtual machine. You know virtual machine, right? Like you can have a Windows running on top.
Yeah, I know the virtual machine.
Yeah, so this is a similar concept, but it's a little bit lower level. So you can think about it's virtual machine as containers. So the idea is that when you run a virtual machine, you have a VMware or like VirtualBox. You have that a full operating system, right? So Docker is kind of similar. You can have probably I don't have any, but if you install the Docker daemon and what it looks like is it's a lower level. You can think about it called it's a container management, but you can think about it, it's like also somewhat like a virtual machine kind of managed. We call it like engines or container. So each container is like a smaller VM or like like a VM, but it's much lower level. You can have those images. So different images is like a different. You can think about a different operating system or different software. So you can run different software with this isolated environment in a so-called container. So you can have different container running different software, and have them isolated. So it's especially good for version control and doing a repeatable developer environment. So you will see a lot of the software is released, and also like the developer environment is also composed of Docker images, because they use this. For example, if we go to like a Jupyter, I think maybe like a Python notebook scene. Not sure you're familiar with Jupyter, like whatever it is. So all like those kind of database systems, because sometimes you need to install a lot of software to get the final to get some software running. There are a lot of dependencies, things like that. So for example, like if we want to run like a Jupyter notebook, or you want to run like some like MySQL database or Postgres database, you can either download the pre-built binary to your system, run it, or you can compile from source, or you can also like download using Docker to download like already built image. It's like so it has a registry, like an index for all the different called Docker Hub. So like, you can think of like a lot of softwares. Like, so this is particularly have they already built this as a box, right, as a container for those different software, different versions. So you use those commands, you pull a different version, and you can run them, and each version is type of unique version. So if you want like MySQL, or you want a database, you want a different database, if it has like official Docker version, you can kind of just use this run a simple Docker command. You can kind of have that version of that database or of that software running up and running. There's some concept of like port forwarding, pretty much like a VM, and also like network concept. The idea is you can get a software with this particular version up and running very fast. There are also like more advanced things, like you can have multiple software running using multiple containers. Right? One is a database, another is like a web app. So you can package these different things in one package, in one like a compose with like a specification. So I want these two things to boot up at the same time. So I have a database. I also have a web app. So this is particularly useful for developers to have a repeatable environment to avoid the problem of why this working on my machine but doesn't work on your machine, right? Because people working on, they make it a Mac machine, make it a Windows machine, make it a Linux machine, and even they get the same operating system, they have different versions of software, like Python. Some people working on their system default Python is 3.8. If it didn't upgrade, it's like 3.6. Like Node.js or any software, any language have different versions. And if you're on different version, you sometimes, most of the times, the things might work, depending on what you're working on. But once you get into some kind of subtle bugs, you have those caveats. Right? It's a lot of waste of time if you cannot repeat your environment, cannot reliably repeat environment. Also, for like service type of things, right? So for software running on a on the cloud or on a like a managed infrastructure, Amazon or Google or Azure, Microsoft. So the server's machine most likely is different than your desktop machine. Like even like a lot of like a Linux box, and they are running on maybe Ubuntu, maybe like CentOS, maybe like a Red Hat, like different operating systems. So those systems has their base softwares. Right? They're like C++ versions. Even some of the configuration, like low-level configurations, are different. So Docker kind of solved that problem by call it a container. So everybody is supposed to, if you pull the same container with the same version inside a container, it is it's very like it's very much the same thing. Well, with some caveat if you really go to lower level, but this is like the de facto today, right? The de facto developer kind of environment setup tool. Another thing is for like those kind of, you heard those kind of maybe like large scale scale the service. We heard like how do we scale the server to serve more people, to serve more requests or traffic. Like I have very popular like social media or e-commerce service. How do I create a lot of servers to serve the requests at the same time? So if you have all the containers with the same version and have them you can quickly boot them up. You can kind of routing your requests to the same instance or the same service. Like usually like a web service, you have people buying stuff on an e-commerce website. They kind of can, the traffic have the same pattern. They can be served with the same web application, but you need exactly the same web server with exactly the same code, maybe with some configuration difference, like partitioned by like user's region or something, but pretty much the same code. It should be reliably deployed or provisioned as your traffic skill. So this is those container like Docker is also very useful for. You can spring up a lot of same software on an identical container, right? So like similar like a lot of VMs with the same configuration, with the same code, with maybe with a different configuration for routing people's traffic. But in that way, you get a reliable, identical environment. So that's pretty much the Docker thing. So it's also used for so-called CI/CD, like continuous integration or continuous delivery. Basically, like automated running some script or building something. It's all about automation. Right? So for this particular software, ideally, you want to check if you change the code. Does it break anything? Does it still build? Right? Does it still pass the release or the test? So those like GitLab or GitHub or this kind of software hosting website that provide the service. Like you can actually run your code in their hosted environment. They provide the compute resource. They provide the Docker containers. They provide okay, now you have your code. But after you change your code, right, maybe you merge your code, you want to run this code in a container. So here image means like it want to run your code in a Rust container. So so Rust has its own containers with different versions, different tags. The latest special one is always latest, but other ones you can specify particular version of particular version to run your code. So here, this particular file, this YAML file, GitLab CI YAML file is provide a configuration to say what are the script you want to run after the code probably get merged or get branches, or in what on what triggers, and what should be run, and use what's the base image. So here we want to check if we can still build. The cargo build is the command we build software. So we want to check when we merge the code, we want those different script can still be built. So we do this cargo build. So this is maybe we can see something in action. So here a CI tab, there are some the actual runs. After it runs, it shows the logs of running that command. So running that actually this, so GitLab in this case also provision a compute container with some kind of runner. It is checking out the code. It is doing it install the it actually runs those checks and compiling. Right? So you run this cargo run this command. Essentially it also clean up things, and nothing breaks. Jobs succeed. So we configure a bunch of them. We build different targets. There are core components. There are several different components. So you can see it is automation, automated. So this is the actual cargo build. So it is downloading a dependency specified in this project, actually run it and see if it breaks. So if it breaks, I think there are some examples. This one break. It's a very good way for notifying developers your changes break your code, right? So you cannot just you need to fix it. If you don't fix this, it's called a regression. If you don't fix your issues for quality controls. So this is a so-called CI/CD continuous integration, continuous delivery. So it's an automation for detect your bugs, or automate to run the script over again if you can have them specified. So so that's bring up another topic, is the more tests you write, the more presumably more robust, or more things you cover. You can use the machine to help you to checking your quality and software quality, but not necessarily the more the tests you write, the more productive you are. Because if you think about the process of development, it's always going to be breaking something by improve it. Something always going to break something. So all your tests is also going to change, right? If you get rid of something, your tests may not be the same anymore. You're going to write in new tests, things like that. And also this way it gave the proper separation. It creates separation of concerns. Create like you can have different roles. If you're in a really big project, you may have people like specialized writing, just writing the software, right? Just creating new features. You may have people specializing in.
Hello, I'm back. Sorry, 我的那个 internet crashed.
Okay, cool. So, continue talking about like this, this CI/CD. It creates the separation of jobs. You can think about like you can have people specialized in writing software, adding new features. Then you can have people specializing in writing tests, right? And there is also title like release engineer. So it's itself could be a full-time job if you have multiple device, multiple targets to be released. There are very different caveats in like Windows system, Mac system. So like we have this CI/CD, you kind of create proper responsibilities for different teams. Okay, so we talk about this CI/CD part. The next one, like any questions? No questions. So basically talking about this file, like this YAML file for creating automation, for creating like automated tests run after you build software. Okay. So if no questions, we're gonna talk about like those scripts. So there are a bunch of scripts like cargo olint, cargo wlint. So those are something which is some scripting we call like xtask in Rust. So here we have like a separate Rust project. It is a use some dependencies. It's used like xshell and some flags. So this xshell project is a wrapping. Is a script wrapping. Is a wrapper around the script for different platforms. So if you look at the code for like those release scripts, right? Like we want to build. So here we have some macros. So like those exclamation CMDs. So those look like a shell script. We have build, have features, have release. We want to build and things differently on different platforms. So here, like we have this config target to check what system it is. Is it Linux or Windows or Mac? And it's different. We set the target as different target, right? Different. If it's Linux, it's Linux. If it's Windows, it's Windows. If it's Apple, it's Mac OS is Apple. And it's kind of doing the package, the similar package. So the CMD command, maybe it's easier to have the IDE is open. So here we see the CMD is defined here. We have like CP, a copy command, make dir, read dir, remove command. The CMD command is executing a shell script. So this is a Rust program to normalize, to kind of use the same code, but run different shell command on different systems. So you can imagine, like on Mac and Linux, actually some of the command is like this make.dir command or cp command is similar, the syntax, but in Windows some of them are a little bit different. So this shell create, like this package, help us to normalize the difference. So here we try to do a release by build those binary files, those targets. We build the graphics interface program, the ISD program. We also package the extension, and here is there are compression steps. So we actually gzip those files together. So this Rust program kind of using the if we see this, I need the pool. Okay, so it's next task. So this program is trying to do release by normalizing those commands, by using this shells script to package things together, and also doing customizations depending on if you're on different operating systems. So here we have 3 operating systems. You can imagine some of the command, if you're directly running them on different machines, the syntax will have some caveat. So this way, it's written in a program, right? But equivalently, we have previously without this, we're doing this in script. Like for the Electron build, here is the actual release program for the Electron build, like the app image. So if we want to release the Electron build for Linux machine in an app image format, so this is a shell script for building everything from scratch, and then using that builder to build out the release version, and then essentially move it around. So this is a script can only be run in a Linux machine. It cannot be run in a Windows machine or Mac machine. And we have other release script, like release Mac. It's very similar but different. Look very similar than the Linux one, because Mac and Linux very similar. The Windows one I don't have one for Electron, but if you want to write it, we have a similar thing. So those like xshell, like xtask, this project, like a Rust project, they kind of mimic the same thing. Right? You can also achieve this with a shell script by writing different shell script for different environments, and also trying to kind of mimic the behavior. What is see here? The advantage of this is you kind of writing like the Rust program, so you make this logic like inside Rust program. So make this project like self-consistent. The drawback of this is you do lose the the script, right? Script is very straightforward. If you test on different machines, it's directly to the point. Each command is very clear what it does. If you write the script in this way, you do get some advantage by have more flexibilities, because usually a programming language is much more powerful than a scripting language in terms of if you want to have more customizations, if you want more logic, you can. Well, shell script is also powerful, but once you started to get like some logic in here, right? Some data structures, you want to do something like in shell script, you don't really get proper functions or getting those like class or like even array or dictionary or maps. So at that point, the script becomes much harder to maintain. So in a program, even you are writing like those building script, this cover build script, and also like this gzip. Under the hood, it might. I'm not sure gzip is using script or not, but under the hood, they're doing similar things. You have more flexibilities. But the drawback is if you're writing a program, it's not that terse, it's not that concise than the script. You have all the noises of the programming language. So there are pros and cons. But you can see you can definitely do one thing in different ways. Either in a program using like utilities like those shell script package to normalize the interface and have some logic, but you can also like writing a shell script yourself. So this is some new additions for the X task. There are some other progress like the internationalization, like language support for different display if you're choosing different language. So we can try to see if this actually works by building it. So you can see like if you want to support different language, like software has they call it localizations. So you have different folders. Usually you define some kind of mapping table with different language mapping to different variables. And if you have the same variables defined, what localization does is to change the key value pair, to change the value of this key. As long as the key is the same, what it actually does is just when you change the language, you just change the rendering and replace the strings with different language. Also, this opens the door for like, outsourcing the translation to non-technical people. There are actual service like translation service for software, also like some kind of online service for I think some project actually using them. So they hire like not very technical translators by exposing kind of just this mappings, because you can hire people like speaking or like you can kind of replace the string with the Chinese version. You can also replace string like a Japanese version or some other version. Like that translator do not need to understand all the other part of the code. Right? So this design kind of helping to streamline that workflow. There are actual service built on doing that. It's like there is some service you can have specify like this is a folder of my translation subfolders, and I can hire the non-technical people to help in creating those multiple different translations as long as they follow the same convention. And after their translation is done, they can directly like create a pull request, kind of having their translation available to be merged into the code. This design is not only it serve the purpose of also like separation of concerns, separation of job duties by practical reasons. If you want a lot of language, you need to have a very easy way for different people with different skill sets to collaborate. Let's see, actually this build, let's see if this actually works. I think last time, like when I have like zoom and screen, like if I'm using, like, I kind of lose the click. Not click. Probably today is the same thing. It's very strange. So probably I can still not click on this thing. But I think you get the idea. Like this UI. So we can actually take a look of the there are also some font changes. Another thing is which probably is the last piece to kind of fully translate, to fully replace the functionality, like we can call a feature parity of this UHL app to this Rust desktop app is a time range selection. So here we have like a time range selection. Essentially, it's a filter of from date and to date. So currently, I think this UI, this Rust UI, already have mostly all the other parts. Even the syncing, the server part, like the working, but it doesn't have the time range selection part. So it is actually, if you think about it, this is actually somewhat complex, right? Like we have a visualization widgets for selecting a range. Even the result is simple. For the other parts of the program, we need a date range. So it's basically two parameters: your front date, the front date, and the to date. But the interaction itself, like the graphics part, is actually not that easy. So this seems easy because we are using web technology, like the charting part, like the graphics visualization part, is kind of standing on the shoulders of those web visualization component. In this case, it's using like data-driven components, using like something built upon like these3. Like it's a JavaScript libraries to do like all those fancy charts. So this is a pretty mature and also over the years, right? It's not like you want to do those fancy visualizations, and the browser engine support those type of things. Like people work on this, like work on those visualizations for many years. If you want to get like those charts, people work on those JavaScript libraries for a long time. But if you are, I think the thing we're using is called dc.js, which is like time series, kind of using this data range, similar to this data range selectors. And so it's very dynamic. Like you select a different range, it kind of updates the different charts. Like all the charts is using the same data, using the same data, using the same table under the hood, and it just represents this table structure in different charts. to get this kind of capability, right? If you look at the documentation for how to use this, like and its dependencies. Right? If you look at the dependencies in the JavaScript side, it's actually some of them not but you can kind of see the history of building this kind of visualization. So the current state for even the Electron, a lot of people choosing using Electron is exactly for the same reason, right? If you want to develop some native graphics component, a widget like this, in a new language, right? Let's say like Rust in this case. If you want to do this, you don't have the ecosystem, or you don't have like some other people's work kind of helping you get there. So this behavior, you can have a relatively low effort for kind of looking at other people's example. Okay, I have this behavior, this data ring selector. So we kind of relatively low effort for getting this behavior once people having it, to move it here. So all that, like this feature is more or less the risk of failure of doing this is relatively low because it's already there. For a new one, you don't have that. You need to kind of build your own. So we're facing this issue of like we want to really replicate this like exactly same user interactive experience here. It's going to be much larger effort because a lot of this drawing, the low-level drawing, the low-level graphics thing is not there yet. So eventually we may like just doing a simple version, like probably select the from and two dates. So that's kind of trade-offs like when you're working on a software project. It's so different pieces that mature, different mature at a different stage. So another thing, I think feature-wise, right? Like if you look at the and I'm relatively happy to see they can achieve this parity, even like the issues, like the performance issue, some gadgets not there. One thing about like the particular UI interaction is this delete button. So currently, if I click delete, this record goes away immediately, which is not a like if I delete, this record goes away. So if you look at a good design, like this, like delete is like a destructive operation. You may want like a pop-out. You see like cancel, or if you want OK or cancel or not OK. So here, if we want to add in that like a pop-up, it also become a challenge because that pop-up is not that really. So like you pop up new window. So for Electron it's relatively easy. You can always like pop up new window and close it. But for ISD, for Rust, right, the pop-up actually also is not readily available. So people still developing like those kind of behaviors. So we're facing that issue. Cool. I think we're almost done. But that's kind of the update for the progress, and I think also chat about some other tools. I hope this will be useful, and probably will see you next time. Bye.